Hello, everyone. Welcome to RSA Conference 2021. My name is Erin Sindelar, and I am a researcher at Trend Micro. While I'm presenting today, please feel free to ask questions at any point because I will be watching myself with you, which is going to be really weird. But I'm really excited today to talk to you about an easier approach to cloud security. I say easier, not easy. Don't get your hopes up too much there, because it will take some effort still, but it does help avoid some of the common pitfalls we see. The cloud is a fascinating place to build solutions for customers. It provides easy access to levels of technology that simply weren't available 10 years ago. It allows you to launch the equivalent of an entire data center with a single command, which is kind of mind-blowing when you think how far technology has come. But there are challenges that come with this power. They kind of fall into two categories, and we'll talk a little bit about both. One is with the technology itself and securing it, and the other is with people. And I don't at all want to imply that people are a problem. I just want to acknowledge that sometimes teams have a hard time working together well. And that is a historic problem that I'm sure you've all experienced yourselves. And it might be the more uncomfortable one to talk about or give you a little bit more discomfort while you're listening. So we're actually going to start there because we're friends now. So we might as well start with the harder part. There have been differing opinions between the seemingly contrasting goals of developers and security teams forever. And that has only gotten harder with cloud acceleration. We recently wrote an article called The 4-Box Problem, and it started with these two boxes of developers and security. The goals seem to be in contrast, but we'll talk more later about the fact that they're really not, but it does cause a lot of a problem now. Over time, with the growth of DevOps, the development and operations processes have been separated differently, and technically, security is an operational effort for cloud environments. However, that doesn't mean that ops teams took on all of the security efforts for anything in your cloud. In fact, most of the time, security is just as separated as it was before when we just had two boxes. Most recently, we see more and more large enterprises introducing cloud ops teams. These are really interesting. They bring all of the cloud people into a single team, and that includes security. It's the closest that security comes to cloud development and actually being embedded in the cloud development process. It kind of, from a security perspective, creates a mini SOC for the cloud, which is pretty cool. But regardless of where you fall in this 4-box problem, over time and the evolution of this issue, security is kind of just pushed around, or more accurately, the person responsible on the development side for working with the security team is moved around. And the core differences in those goals persists regardless of how it works. So we'll talk more about how the goals really aren't that different in a little bit, but first let's talk about the technology. With the growth of the cloud, it would make sense to assume that we would see more of the same problems that we see with on-premise environments. We should be seeing more 0 days, exploit chains, ransomware, day-to-day security stuff. But it turns out that's not the same problems. In fact, it's not anywhere close to the top of the concern list because misconfigurations are actually the biggest security concern in the cloud. Research from Trend Micro and many other organizations has shown that between 65 and 70% of all security issues in the cloud start with a misconfiguration. And there are other threats to cloud environments, absolutely. In the past year, we've seen a definite uptick in Linux-based malware and crypto miners that are targeting cloud platforms in the wild. But they have a long way to go before they overtake misconfigurations at the top spot. I say they have a long way to go because if you look at all public records of cloud attacks and filter out things that weren't actually due to a cloud issue, over 2 billion sensitive records have been leaked. And in all but one case, that was due to a single misconfiguration. One wrong setting, one error or mistake, led to all of that data being exposed and all of those breaches. The one exception, the more complicated event, was the Capital One breach in 2019. You likely remember the incident because it made a lot of news at the time. And this more complex event was due to two misconfigurations and a bug. After the fact, an in-depth analysis was done that actually found the bug was inconsequential to the end result. And that impact was 100 million user records leaked. And it essentially came down to two misconfigurations. And the team at Capital One are amazing cloud pros. They're an AWS reference customer. They've been a huge advocate in the community for cloud. They know what they're doing, but everyone makes mistakes. And the rate of change of the cloud makes it kind of understandable. At the end of the day, misconfigurations really are just mistakes. Sometimes those mistakes are due to a lack of awareness. Other times it's a missed opportunity or something that was just an oversight. But regardless, the mistakes still happen. Now, this might seem a little far-fetched. It might seem hard to believe that this much damage and this many breaches could be caused by simple mistakes. You might wonder how that's possible. And I will answer that question. But first, there's a common misconception about cloud security that I feel like we need to address before we move further. It's often assumed that the cloud service providers themselves are a major security risk. That might even be why you have held back or gone a little slower in digital transformation in your own organization. However, this concern hasn't been found true. In fact, there have only been 2 breaches across all 4 of the biggest cloud service providers in the past 5 years. Now, they have had to deal with vulnerabilities. There's always vulnerabilities in code. But those are mostly due to the fact that a large number of cloud services are simply managed service offerings of popular commercial and open source projects. And if those projects have a vulnerability, then the platform has to deal with it as well. So regardless, despite all of the vulnerabilities that have been dealt with, there have still only been 2 breaches. So lay that concern aside, it's not a problem, and you don't need to worry about the cloud service providers themselves as part of your security risk assessment. So back to misconfigurations. Part of the challenge is the rate of change of these 4 big platforms. In 2020, the Big Four released a total of 5,000 new features over the course of the year. That's a lot. And when you do a little bit of math around it, it works out to a minimum of 2 new updates or features per day for single cloud users. I imagine that many of you are multi-cloud users, and therefore the number of features a day being introduced potentially into your environment just exponentially increases. That's a very high rate of change, and the vast scale and speed of the cloud service providers makes it hard to manage. Some approaches that we hear to organizations moving into the cloud is that they want to take it slow, because if they go slow, they can minimize their risk. There's logic there, yes, but even if your team is moving slow, the cloud service provider's on it. So you're only really minimizing half of the risk in that type of concern. Overall, managing complex cloud environments is maybe a little daunting or overwhelming. And we know that these simple mistakes and configurations can lead to just enough of a foot in the door that an attacker needs to wreak havoc in your environment. So fortunately, to address some of this daunting task, we have the shared responsibility model for cloud. This dictates how any operational work is managed, whether it's the responsibility of you as the organization or the cloud service provider. Now, remember I said that security is part of operational work for cloud. That means that if you're running instances or virtual machines, you're responsible for the operating system, the applications running on that OS, and any data within, including their security, all the way over to the right where your in a fully managed service, and you're only responsible for the data being processed and stored with that service. But no matter what, you can see along the bottom that service configurations are your responsibility regardless of what type of service you're running. When you think about it, it makes sense. No matter what type of technology you're plugging in, once you turn it on, you have to set it up to work in your environment. The default configurations are just the recommendation, but that might not be what works best for you. So what's the fix? What do we do to address this problem and keep these mistakes from happening? Well, we're human. Mistakes are going to happen. But fortunately, we can put technology in place that can minimize the risk that these mistakes lead to a security event. And that's where security controls come into place. You're likely very familiar with security controls. We are in the security industry. So you might be wondering, well, these security controls exist for cloud environments. So why do misconfigurations keep leading to breaches? To answer that question, you have to start thinking like a cloud builder. And now I'm going to ask you to remember a few minutes ago when we talked about the 4 boxes and the seemingly disparate goals between people in the development and the building side versus the people in the security side. The goal of security is actually really straightforward. We are always working to ensure that what is built works as intended and only as intended. The difference with builders is that their focus is on just the first part. They want to make sure that what is built works as intended. And in the cloud, they want to make sure that this is happening really quickly. Why build in the cloud if you're not able to build fast and with a lot of agility? And that's really a lot of the benefit. So that's kind of where the initial disconnect lies, the heart of our problem, that developers want to go, but security says no. And it's not necessarily that we want to say no, but sometimes you don't have a choice. To ensure that something works only as intended, you have to make sure and have a little bit of time. So you might need to say no or not so fast before you do something, because the builders have made sure that it works as intended, but you have to make sure that it only works as intended and can't be abused or misused. In a traditional environment, on-premise, a strong approach to security involves a good perimeter and deep visibility across the environment. Unfortunately, that doesn't translate exactly in the cloud. The perimeter doesn't exist in the same way because things are being spun up and down constantly. The teams are smaller and building more and more faster. And depending on how the teams are set up, you might not have easy access to the builders. You might not actually be able to put security controls in place in the cloud environment, which can make it difficult to secure. Fortunately, there are 2 questions that can help us think more like cloud builders and start addressing security in a way that will be meaningful from the cloud builder's perspective. Those are, what else can this do? And are you sure? They're really simple questions, I know, but as we go through some examples, I think it'll make sense that these are critical for making security controls matter to cloud builders. For example, the container that runs the code that pulls the financial reports. What else can it do? Can it access any other data? Are you sure it's always the right container that is being accessed? This is where security controls really provide value for builders. As security teams, when we talk about security controls, we talk about all the ways that they stop things from happening because we want to stop the attacker. It makes sense for us to say that using an intrusion prevention system stops worms and other network attacks. Anti-malware stops ransomware and crypto miners and any other malicious behavior. And those are great for us as the security experts. But remember, builders want to build and fast. If you come in saying, here's these great security controls, they stop all the things, that's not going to be very interesting to someone who needs to continue going constantly. Those roadblocks are a major hazard in the cloud development process. But fortunately, it doesn't have to be that way because security controls can do more than just stop bad things from happening. They can actually enable us to build better in the cloud. We just have to frame them in a different perspective so that they have more meaning to the cloud builders. Let's go through some examples. We're going to start with posture management because it's really the cornerstone to addressing our misconfiguration challenge. We know that that's the biggest security risk in the cloud. So the thing to do to ensure that that's not a problem is to have a posture management tool. If you don't take anything else away from today, I have to tell you my secret that this is the thing that I hope resonates the most. Trend Micro's Cloud Security Posture Management tool identifies more than 840 million misconfigurations a day. So that's a lot of opportunities for attackers to get in if they're not addressed. So with that type of scale and all of the reasons misconfigurations are a problem that we've already talked about, this is really a critical security tool for you as the security person. From the builder's perspective, it also has a lot of value. For one, they're not going to have to check that every setting stays set every time. These teams may be deploying hundreds of times a day, and no builder can sit and make sure that every setting is right every time. There are all the compliance boxes checked and everything is in order. That would be more than a single person's job, and it would be miserable to make sure of that. Fortunately, these tools do that. They also help with cost management. It will tell you if something is running unnecessarily or in a way that could be optimized so that you can spend less or spend more wisely. If you're in an industry with any type of compliance or regulatory measures, this will also help you if you're ever audited because you can prove that your environment is running in compliance with whatever measures it needs to be. So, big takeaway, cloud security posture management tools are hugely important. Beyond that, though, despite all of the value that they provide, there's a lot more to the cloud environment, and the rest of it should be protected too. Network controls assure teams that only valid traffic is hitting their code. From the security standpoint, only valid traffic means that nothing potentially unwanted or malicious is getting in. But from the builder's perspective, it means that nothing unexpected is going to hit your code that will stop it from working as intended. So again, it hits both points of our singular goal. We're all trying to work to make sure that things work as intended and only as intended. Application controls add more of the same benefits that building applications in the cloud offer in general. They help with the speed, reliability, and innovation of cloud app development. Including security as part of the automated testing process in your CI/CD pipeline upfront means that any type of bug can be addressed from the beginning, whether that's a bug in something working as intended or only as intended. That way, something can be deployed, a new app or feature that can get out to your customers faster and more reliably. It means that there are no longer times or instances where a new app is released and security finds an issue a week later and it has to be rolled back or another update has to be pushed out to fix it. That's really unnecessary, and that's the part of security says no that builders really get frustrated with because their work is already complete at that point. It's out the door. But there's nothing the security team can do about it if we're not built in to the automated testing process from the beginning. Container emissions controls ensure that the right container is deployed at the right time, every time. And container image scanning helps ensure that only what is expected is in that container image. Snyk has a really great report that's linked here called the State of Open Source Security, and it's something that they run annually, and it consistently finds that official container images include a lot of vulnerabilities. These aren't just any container images. They're the most popular and widely used. It's quite possible that they're being used in your container-based environment currently. But you might not ever be aware, nor the builder, if there aren't security controls in place unless a security incident happens. That's definitely not the time that you want to find out that there was a vulnerability in that container image. So these controls can make sure none of that is going to happen upfront before the container image is pushed through. In the same vein, any open source software can have vulnerabilities, and you're likely aware of that. Open source code is readily available and heavily relied upon for good reason. We use it in security all the time as well. But from the security standpoint of protecting your company and your environment, it could be a big blind spot. You might think about it as having hundreds of developers who don't work for your company, but their work is part of your production code base. That might be a little scary because you don't have any visibility into what is there. If a vulnerability is found or an update is pushed out, you don't know about it. If the builder knew about the vulnerabilities, they would likely fix it, but they don't have any better visibility than you do. Once it's out, it's a dependency in their code that will be built upon, and unless something is known to be a problem, they're not going to go back and mess with it because it works. Why mess with it? So to address this blind spot, from a security standpoint, it's pretty obvious why knowing about open source vulnerabilities would be a good thing. From the builder side, there's the added benefit that these types of tools can let you know if there are any specific licenses that need to be in place in order to legally use that software. That could be something else that whoever the developer was at the time just wasn't aware of. So it can cover a lot of bases and make sure that nothing is going to come in, no attacker is going to exploit this vulnerability and hurt either team's goals. Security controls can do so much more than just stop things from happening. They can help us answer critical questions that builders are starting to ask, like what else can this do? Very little because of these security controls. But are you sure? Yes, these security controls told me. Security can really be an accelerator for cloud innovation. It can help teams build better in the cloud when it's done well. But for cloud builders to really know that and embrace it in the midst of their constant change among their teams, among the cloud service providers themselves, they have to see that making security part of the build process is going to be beneficial. We're not just the team that says no, we can help build better. To do that, though, we have to stop talking about what security stops. I know that's a little complicated to say. That's fine amongst ourselves because as the security experts, we want to stop bad things from happening. But when talking about it with other teams, we need to say what security enables and show how security can truly be an accelerator for cloud innovation. So how do you do that in your organization? Start by identifying what all cloud services are there. You likely have an idea in mind, and it might seem like a silly thing to think about, but I doubt that all of you can say with 100% certainty that you know all the things that are making up your cloud footprint. Once you know what's there, identify what security controls are available. The cloud service providers are really helpful for this. They will absolutely point out where security controls can be applied. This is also a good point to have a really strong cloud security partner, because if there are security services in place that are built for the cloud and in the cloud, then they're built, or they should be built, to enable the cloud process. No security tool in the cloud needs to slow anything down. So you want a partner who isn't going to slow you down. Once you understand what's there, translate that value into something that matters for the builders. Ask, what else can this do, and are you sure? Think about how the security controls can be an enabler to the build process rather than a roadblock or a hassle after the fact. And then communicate that value to the cloud teams. I guarantee, I highly believe that if you have this conversation about what security can do for a builder instead of what it can stop, it's going to be a much more productive conversation. And I bet they'll be on board with security controls when they're presented in a different manner. And then turn it on, see what security controls are available. How many misconfigurations does your posture management tool find? Ongoing, not just up front, because it should be automatically running all the time to flag anything new based on the new features from your cloud service providers. Once everything is turned on, sit back and enjoy. Work together ongoing with your builders and however your cloud team is set up, because I'd be really curious what the return on investment is if you can calculate whether anything is X amount more secure because of this new approach, or if in general it's just easier to go about security in the cloud because you're working together and it's actually part of the build process. Thank you so much for your time today. I hope you learned something, and I really hope you are enjoying the rest of RSA 2021. I look forward to chatting more and answering any more of your questions in the chat. Thank you.